Hey, what's up guys? In this video, we are going to be building a MIDI to CV module. This is the finished project here, finished product, and it is a fun learning experience. The point I want to make is, I don't have the best hands these days, and if I can do it, I think anyone can. So go into the garage, grab a soldering iron, order a kit, and yeah, give it a try. The link to the kit will be in the pinned comment below. It comes with basically everything you need and some very clear instructions. And yeah, it's pretty fun. The pick comes pre-programmed. And yeah, we're going to hop to it right now. So the first little clip, I made a kind of a basic theory of operation, and then some guy in a vest is going to kind of go through the process, and then there's some narration as well. So I hope you guys enjoy. I hope you learn stuff, and see you on the other side. All right, so basic theory of operation. What we want to do is we want to convert a MIDI signal into CV. MIDI is data, CV is voltage, and you'll have varying voltage depending on what note you're pressing and all these sorts of fun things. We need to convert this. So how do we go about doing this? Well, let's do a basic little diagram. Let's get a MIDI 5-pin friend here, and the MIDI data comes in from your DAW, whatever you want to call it, your foot pedal, your tracker, whatever it is. And this goes into the MIDI in, and this will have data of what channel it is, what note, velocity, aftertouch, all sorts of fun things. And this is all wrapped together in the MIDI standard. And it's, yeah, I'll just do dots for it's a digital signal. Yay. Just ones and zeros. Okay, so we need to actually decipher what this data is. So we will use something called a pick. And the pick is essentially that long thing that came with your kit. This is pre-programmed. It is a programmable integrated circuit. PIC, programmable integrated circuit. So we can program this. So we can say, we can just be like, hey, this is how you decipher MIDI. And it says, cool. So the downfall of picks is, well, in electronics, it's a lot more efficient to kind of offload. If there's a chip that is like really good at doing something, then you use that. A pick is not really good at one particular thing. It can do a bunch of other things, but since it's programmable, it's not really efficient to have that take that digital signal and convert it to analog right away. What it does is it converts the MIDI information into a digital audio signal. Let's just say that. It'll convert it, and that will be sent over a bus to something that is specially built for turning digital into analog. It's purpose-built for turning a digital signal into an analog one, and this is called a DAC. And DACs are in a lot of things, and what they are is they are built in the manufacturing process to turn a digital into an analog signal, digital to analog converter, right? So these two friends work together to accomplish the task of turning MIDI information into CV, right? So again, right, MIDI comes into the pick. The pick will convert that into a digital audio signal, right? And the DAC will convert that into the analog audio that we enjoy. Only problem, well, not really a problem. a consideration is this DAC outputs at very, very low voltage, right? We're working with 1 volt per octave, so could be a problem here, right? So that will be sent to something called an op amp. And we'll use, in here there's the TL074, and that is a dual channel op amp. And what an op amp does is it essentially just uses something called feedback or feed forward or whatever. And what it doesn't, it's not important what its operation. What it'll do in this board's case, it will boost the analog signal. And yeah, this is called an amp, or an OP amp, right? This is, the TL074, right? And yeah, the DAC will convert this to an analog signal, and then this will be sent out to our outputs, right? And, this will be sent to, CV, gate, all sorts of fun things. I think in this particular case, the gate is, it's sent via a transistor. Yeah, the gate is actually sent out via a gate. So yeah, we don't need to kind of worry about its the op amp. I think the op amp is reserved for CV out and auxiliary CV, and everything else is still controlled by the PIC, but it's sent to the gate. So there is the basic theory of operation. Cool. All right. So in this video, I like how the camera's all slanted. It's like super extreme. We're going to be building a MIDI to CV kit. And what that means is we're going to be doing some soldering and all sorts of fun stuff like that. It's going to look kind of like this when we're done. So yeah, let's hop to it. Let's see that we have all the parts here. So me being a silly person, my overhead camera was picking up some audio. It's picking up mostly the audio of my fume extractor. So it's basically unusable audio. In this part, I'm essentially just going through the contents of the kit. But if you already have a kit, you kind of have the contents right in front of you. So yeah, you already know that. Just put it in a Tupperware container and just kind of have everything out. And you will be taking things out of that container as you go. First thing we're going to do is we're going to be populating the logic board with some diodes. Now, diodes do a really cool thing. They only allow electricity to go in one direction. So they are polarized. So they have to be put in a certain way. The line on the PCB and the line on the actual diode itself has to match up. If you put them in upside down, your board won't work. The reason why diodes are important in the world of modular synths is it prevents reverse polarity. It's reverse polarity protection. It's really magical. So say if you have something plugged in the wrong way from your power supply, it will actually prevent that DC current from going in and frying your components. It's just a layer of protection. So yeah. And what's really cool about these components on this strip is they are actually in order as per the instructions. So you want to take the diode out and bend them like so, and then just place them in the PCB. So what I do is I place them through the holes and then I bend them in such a way so that they stay in place. I flip it over and I solder them. And then I get some flush wire snips and then cut off the leads. And then there we go. Next up, we're going to be placing the crystal in the board. This is a clock. What it is it's a crystal that kind of oscillates at a very predictable frequency when current goes through it, and it gives it a clock. The PIC is essentially a computer, and it needs a clock in order to operate and do calculations. The DAC as well. It's very important. It operates at 20 megahertz, and it has no polarity, so you can put it in any which way. I prefer to not bend the leads because it's pretty fragile, and what I do is I essentially just tape it in and then it's good to go. And then I solder it in and then snip the leads and then I'm done. Next up, we are going to be populating the capacitors. There are two kinds of capacitors. There are ceramics and there are electrolytics. Ceramics have no polarity. They can go in any which way and they operate the same. Electrolytics actually have polarity, and if you put them in the wrong way, they will explode. So make doubly sure that they are in the correct orientation. The longer lead is positive, the shorter lead is negative. Also on the side, there is a strip that says that it's negative. So for the 10 microfarad capacitors, you want to make doubly sure that they are in the correct way. Next up, we are going to be populating the IC sockets onto the board. We have one 8-pin, two 14-pin, and one 28-pin. It's very obvious where they go. The reason why we aren't soldering the actual ICs directly onto the board is because they're easy to damage with heat, and when we're soldering things, it's just kind of a pain. And this way we can swap them out, things like that. If things don't work, it makes things a lot easier. So what I do is I get some masking tape, I tape them up, and then I flip them over. I do one corner up at the top to kind of tack it in. I do the other one just to make sure that it's in there nice and snug, and then I just go through all the pins and solder them up. It's pretty straightforward. Next up are the resistors. It's pretty straightforward. On your sheet of paper, you will have the values and the colors of the actual resistors, so you can easily match them up. Match them up to the numbers on the actual PCB, R17, R22, etc., etc. Double check. They're not polarized, so they can go in any which way, and you just bend them and put them in and solder them up. It's pretty straightforward. Next up is probably the most difficult thing, and that is soldering in the transistor/voltage regulators. There are two of them. They are different, and the leads are actually pretty close together. You want to make sure that you have the right orientation, and just take it slow. And what I did was I did a little bit of a continuity test with my multimeter, and there was no short circuit, so I was pretty golden. And if I can do it, I think anyone can. So right here, I am soldering the headers onto the board. And right here, I am making a major mistake. I'm actually soldering the header onto the wrong side of the PCB. So I had to get out the desoldering pump of shame, and I had to essentially destroy that female header. But what I did instead was I was like, you know what? This is part of the process. You do something wrong, you figure out a way to, fix it. So I got some, single core wire, and I just wired them together. And that's basically what I did. And yeah, it works. There's continuity to there, and yeah, it just makes it have a little bit more character. So don't do as I do. Don't get excited. But yeah, that's just these things happen. Now we start on the next PCB. This is going to be the front panel PCB. And there are a couple of resistors. It's very straightforward. You just put them in and solder them up. However, there are two diodes. They are completely different diodes. One is a Zener diode, and another one is similar to the one on the other panel. It's very important to get these ones correct. I had a hard time trying to figure out which one was which. I was using a little magnifying glass. You really want to make sure that you got the right diode in the right spot, and that the polarity orientation is correct. So double and triple check that before you put that in. But other than that, that was probably the most challenging thing about this particular panel. This next step is one that is in my opinion, a very crucial step that will contribute to the longevity of your electronic devices. And that is that I'm taking all of the components that screw into the aluminum panel. That would be the 3.5 millimeter jacks, this like rocker switch here, 3 point, and then this momentary switch. All the things that actually screw into the panel, screw them into the panel, so the panel and everything is absolutely flat, and the components are flush within the PCB. And with years of plugging things in, taking things out, it'll put stress over time on the circuit board, the PCB with the solder. Solder might crack or what have you, just with variations in the warping and flexing of all these things together over time will contribute, plus temperature and stuff like that. So I want to make sure that it's absolutely flat and snug. I don't want things to be like kind of tilted in a way, because when I screw them in, it'll kind of put pressure on the board. It's nasty stuff. So just a simple thing to do to make sure that there is rigidity in your device. You also want to be very liberal with the solder. This will offer strength. You want to flow a lot of solder in these parts. It'll really make a difference. The next thing I wanted to install was the LED indicator. This is a 3-lead LED. It is both red and green. So the orientation goes like this. The shortest lead is green, and on the other side would be red. So set the orientation to what is appropriate on the PCB. Also, the depth depends on the panel, right? You want to kind of poke out. So, use the panel as a reference, and yeah, just solder that in right quick, and you should be good to go. From here, we place and solder in the Midi ports. We will be soldering in the trim pot for calibration, and then soldering in the USB port. The USB port has very, very tiny leads, so be careful with those. And again, this is going to be under some stress, so make sure that you use quite a bit of solder. Like don't go crazy with it, but just use enough so that you're confident that it's very solid in there, because these aren't actually connected onto the panel like the other components. And what I did here is I put in the standoffs with the screws, and I essentially married the two PCBs together. Next up, we are going to be socketing the ICs. This is a very important step, the final step in the process. So the ICs are very sensitive and fragile. So you don't want to actually bend the legs or force things into the socket. Take it slow and don't overdo things. They each have an orientation. You don't want to put them in upside down, because that just they won't work and all the electrons will fall out. They all have an orientation. So the standard is a little dot in one of the corners. That is the corner that will kind of line up with the PCB. The PCB has a little indent on the PCB kind of drawing, the printed PCB that is. So that will mean that that is the top. And the little dot or the little kind of indent at the one of the two sides of the IC, that'll tell you what orientation it is. If you're unsure, double check, because sometimes there will be kind of a dot on one end. It'll be in the middle, but then there'll be like an indent on the other. Just double check, take it slow, and they will kind of just slide right in. If the legs on the ICs are too spread apart and they don't line up with the sockets, you're going to have to bend them slightly. So what you do is you set them on a flat surface and just kind of bend them inwards, and just take it slow. You can bend them a little bit. You just want them to kind of align into the socket. You don't want to destroy the chip or kind of bend a leg outward. it's a mess. So just be careful, take it slow, and they should go in. Put them in evenly. Don't put them in at an angle. That's bad news. This is a part where it's kind of easy to mess up. All right, so let's plug this in. Well, it's already plugged in, and let's see if it works. Yep. Gate light went on. Press a note. Nice. Gate button is turning on. Okay, let's test something out here. I'm gonna try gate out first, and yeah, I'll do this one, which is B, and then I'll give it a reference to ground right there. Okay, over to Lab Nation. Nice. Oh, neat. I guess that's how gates work. Gate. Cool. Very cool. Okay, gate works. What about CV? This one is a little bit more put together. Why is it zipping back up? That's what I want to know. You know what? You know what it might be. It might be that it really wants to kind of reset itself. Am I working? Oh yeah, because I'm working with AC. Need to work with DC. That's pretty funny. Okay, so let's set that back to, yeah, that should be good. Yeah. Very nice. Okay. Super cool. All right, so yeah, C0 is 0, but yeah, it's pretty stable as we go up. Right? And that would be, yeah, tends to happen. So you have to have your scope on DC mode because it wants to reset after a while. Yeah. Yeah, so it's maximum C8 and it looks rather stable. And yeah, as soon as I have an oscillator, right, I'm just going up and down the keyboard in terms of octaves, right? So I would need to calibrate this, and I don't want to calibrate it with a sine wave. But yeah, it's yeah, it was just me forgetting the scope. Okay, let's go gate again, right? So now the gate is on, off, right? It doesn't just set back down to whatever it is, really. Yeah, it's on, off, yep. So I hope you guys enjoyed that video. I hope it was fun. Next time, my overhead camera is going to pick up better audio because, you know, it would have been fun to kind of upload that whole build. I recorded pretty much all of it, but, you know, not too bad, I guess, for my first, you know, assembly video. So let me know, I guess, if you want to see more of this sort of thing. You know, the point is that, you know, if I can build this, I think anyone can. So yeah, go into the garage, get a soldering iron, and put some stuff together. All right. Hope you guys enjoyed that video. Hope you learned stuff. Take care and have a good one.